Curious how Azure virtual machines and other resources talk to things on the internet? In this video, we'll look at NAT capabilities in Azure. So I think we're all used to the idea that the IPv4 address space has run out, and we're not all ready to just run over to IPv6 quite yet. So how is it we all have all these different devices with all these different IP addresses, but they still work? And it's really all thanks to kind of network address translation, port address translation. The idea being, for example, in our houses. In our house, hopefully your house doesn't look as bad as that, but we have lots of different devices. We have tablets, we have computers, and if you went and did like an IP config or an IF config or an IP, it will tell you an IP address. And most likely that IP address, if you're at home, is going to be maybe a 192.168 something. It might be a 172.12. It might be a 10 dot something. And those all make up kind of this RFC 1918 address space. It's used for internal purposes. It will not route over the internet. But you want to go and talk to the internet. So how does that work? Well, you have a service provider, and that service provider has a piece of equipment at your house. And that piece of equipment, think of it some kind of router, it has its own IP address. And most likely that IP address is routable on the internet unless they're doing another kind of NATing. So you have all these different devices in your house, TVs, whatever, all have their IP address. And so I have a packet. You can imagine maybe this had an address of 10.0.1.10. And it wants to go and talk to something on the internet. So when it creates this IP packet, the source address is 10.0.1.10. When it hits this device, it rewrites the packet. So now its IP becomes the source IP and sends it out to the internet. It does whatever it does, and the response is sent back to that IP address where it has maintained kind of a lookup table. And now when it gets that IP packet back in, it will now rewrite the destination to, instead of being its IP, the original requester, and it sends it on its way. And if it only has one public IP address and lots of internal IP addresses to map to, it can't do a one-to-one mapping. It has lots of internal IPs mapping to one public IP. So what we do is we do port address translation. And you can think about each kind of session, each unique combination of internal IP and port and destination, IP and port and protocol. It maps that like a 5 tuple. And so what it will do is on this traffic that's going out, it will say, well, hey, you are port 10,000. The next one going out, you're port 10,001. You're 10,002 for any kind of unique set of session data. So when it comes back in, it will say, hey, your IP colon 10,000. Well, hey, port 10,000 was this IP and that session. So we can forward it on. So it's creating that mapping. So that's at your house. And Azure really works very, very similar way. We have to NAT the traffic. So if I think about, I have an Azure virtual network. So I have a VNet. And that VNet, remember, is going to get broken up into subnets. So let's just say, for example, I've got subnet 1. And that virtual network is going to use an IP scheme, commonly from RFC 1918. It doesn't have to, but it commonly will. So that subnet is a portion of that IP space. And I have a bunch of different resources in there. I've got VM, I've got VMs behind maybe a load balancer. And they're all talking on private IPs. And if I do nothing else, they can get to the internet. So we have the internet out here, and it works. So how is it doing that? Well, it actually works in different ways. If I have a virtual machine and it has its own instance level public IP. So if I have created an instance level, i.e. it's just for that VM, public IP, and it's kind of linked to that virtual machine. Now remember, this is primarily an inbound construct. I give that virtual machine a public IP because I want it to get traffic from the internet. Maybe it's offering a web service on 443. Now, we typically wouldn't do that directly with an IP, because if I'm offering a service to the internet, I probably want it to be resilient. So I'd want multiple instances, I want scale, I want to load balance that. But if we did, if a VM in Azure has its own instance level public IP, when it wants to do outbound communication to the internet, it will actually use that instance level public IP. That's how it will then go and get to the internet and get the responses. So if I have a public IP, I'm going to use that not just to offer services to the internet, that's what I'm going to do to actually get to the internet. And because it's a one-to-one mapping, a public IP to my internal, I have kind of the full ports available to me. Now, if I have a load balancer, and the load balancer color has a public IP, and again that's used to receive things from the internet primarily, but once again virtual machines behind a load balancer will use that to go and get to the internet. Now there are some different functionalities here. If it's a basic load balancer, that's just what happens. If it was a standard load balancer and it did not have a public IP address, these wouldn't be able to get to the internet. So things behind that load balancer would not be able to get to the internet. As long as the standard load balancer does have a public IP, then the things behind it will use that to go and get to the internet. And that's an important point, because if I use things like maybe private link service, so I have internal load balancers, and I'm using standard load balancer, I have to think about how they're going to get to the internet. So if that doesn't have a public IP, they don't have that access. Now, what about if I have virtual machines? Let's just delete that for a second. Let's extend that subnet out for a second. What about if I just have a VM and it doesn't have a public IP? Well, then Azure just behind the scenes kind of allocates an IP address and it enables that outbound flow. So it's going to enable that to function. But I have no control over that. I don't know what IP it's going to use. It'll be hard for me to go and whitelist a particular service knowing it's coming from this address. And if I have multiple virtual machines, they all may use that same public IP that's just been automatically handled by Azure. So I have really no control of that whatsoever. So those are kind of the three basic scenarios. Now, these are using port address translation when I have multiple, either in this load balancer or when it's just this automatically allocated. So it's looking at, hey, based on that source IP, that protocol, the destination, it's going to assign an ephemeral port that it will map and hold for a certain amount of time before that times out. So when the traffic comes back in, it knows, hey, that port helps it map to who was the source IP address. But what if I want a bit more control? What if I don't like this idea that, hey, I want to offer services to the internet through maybe an instance level public IP or a load balancer of a public IP, but I want to separate the outgoing flows. Now, if I use a standard load balancer SKU, there are outbound flows. I do have some control over that, but it's still a distinct object. And if I use a standard load balancer, well, I have to have knowledge in advance. I have to plan. I have to think about the scaling. I have to explicitly join the virtual machines to that back-end set. There's work I have to do there. So there's another solution. There's NAT Gateway. So with NAT Gateway, I create this kind of NAT Gateway resource. And it can either be regional or it can be zonal. So zonal means it is isolated to the zone I select. Now, I could still use it from resources that are in different availability zones, but you probably wouldn't want to. It's going to break that zone promise. So you'd want to architect accordingly. If I was going to use a zonal NAT gateway, I would have a NAT gateway in each of my 3 availability zones. And then I would have to make sure my subnets, the resources were put into a particular subnet, were all in a particular availability zone. I'll explain that in a second. So with this NAT gateway, this is designed to provide outbound functionality. And once I create that NAT gateway, it has either a public IP, and it's the standard SKU, or it's going to be an IP prefix. So an IP prefix is a set of contiguous public IP addresses. And the way I use this is I link the NAT gateway to a subnet. I could have multiple subnets. So I could have subnet 2. I could link it to there as well. And when I do that, this will now override how things go out to the internet. So even though I've got an instance level public IP, even though I'm behind a standard load balancer, it will not use that for outbound connectivity anymore. So as virtual machines, we'll use those to receive things, but for its outbound flow, so this VM, to get out to the internet, it will actually send it, I'll do the rainbow color over here, it will send it to the NAT gateway. If this is trying to get outbound, it will go to the NAT gateway. So now separating it. This will automatically scale. I don't have to worry about thinking about this thing in advance. I just have to link it to a subnet, and it will automatically take all of the outbound traffic and NAT it for everything in that subnet. So it's much easier to think about from a manageability perspective. It is not compatible with non-standard SKUs. What I mean by that is there's a standard public IP, there's a standard load balancer. These work with each other. If I had a basic load balancer, that inbound flow would cease to work. It is not compatible. I have to use the standard SKUs of the load balancer of the public IP if I want to use NAT gateway with that subnet. If I attach a NAT gateway to the subnet and I just had a basic load balancer, it will not get the traffic anymore. This will just override it. So that's an important point to understand. So this is kind of fantastic. I just create this NAT gateway, I link it to a subnet, it will now be used for all of that outbound flow. I know the IP addresses or the IP prefixes for the NAT gateway, so I can now go ahead and whitelist these for other services that it may be trying to access. Now just one point to clarify then. So I talked before about availability zones. So if you remember, if I have an Azure subscription, if you think about what is a region is typically made up of 3 availability zones. These are kind of isolated sets of resource and power, and water, and communication. So I have this kind of AZ1, 2, and 3. Now in Azure, a virtual network is a regional construct. So my VNet would span all 3 of those availability zones, as was my subnets. So by default, my subnets would also just be spanning all of the availability zones. But if I create a NAT gateway and I make it zonal, so here let's say this is my NAT gateway 1, and then I create another NAT gateway 2, and another NAT gateway 4, I'm kidding, 3, I would need to make sure when I link this to subnets, well, I want all the resources in that subnet in that AZ. So I would have to architect accordingly. So in this case, I would probably create a subnet, and although they are spanning all the availability zones in terms of the construct, I would make sure that when I put compute resources in them, I only put compute resources in that subnet that were in AZ1. I would only put compute resources that were in that subnet in AZ2, etc. So now I can link the appropriate subnet to the appropriate gateway for that AZ. So if I was using VM scale sets, I wouldn't want them to span zones. I would want it just to be in a particular zone, and I would be a particular subnet, and I would not put things in this subnet that were in other zones. I want to keep that zonal promise. If this NAT gateway is in this AZ, I want to link it to subnets that only contain things in that AZ as well. If I put something in this subnet that lived in AZ2, it would still work, but I'm just breaking that zonal promise. I'm relying on something in a different zone. And that's a more complex thing that didn't make complete sense. Don't super worry about it, but just realize that's what happens. If I make a zonal, something that's in a particular zone, I need to make sure everything that's using it from a good architecture perspective is also in the same zone. Subnets normally span all AZs, so it'll be my responsibility to kind of carve things up differently and make sure I only put resources in that subnet that are in the AZ that I'm linking to that subnet. So that gateway gives me a way to control the flow of traffic. If I don't use a NAT gateway, if it has a public IP, it's going to use that. If it's behind a load balancer that has a public IP, for standard, it's going to use that. If it was just a basic load balancer, it will still work. Otherwise, Azure will dynamically allocate a public IP for its usage. Remember, the special case is standard load balancer. If it doesn't have a public IP, they won't have any internet access. I have to do something else. Either give the standard load balancer a public IP or use a NAT gateway. Then I can control it. So let's take a super quick look at this in action.
So let's look at a quick example. Here I've got a virtual machine. It has both a private IP address and a public IP address. If I look at a different virtual machine, let's say, for example, my domain controller, well, it does not have a public IP. If in the web browser, I perform a check for what is my IP, for the virtual machine that has a public IP address, remember its primary goal is to offer services out to the internet, we can see that that IP address that it's using to get outbound to the internet is the same as the one that's being used to provide services to the internet, i.e. its public IP. For the virtual machine that doesn't have a public IP address, well, it can still get to the internet, but it just kind of has some random IP. That's what Azure is just allocating for it and maybe other virtual machines. For example, I have two other virtual machines that don't have public IPs, but they're in a different region. You can see they are using the same public IP. Azure is automatically providing that NAT and it's using the same IP address. Now, what we're going to do is actually create that NAT gateway. Now, you will notice this public IP is a standard public IP SKU. If it was basic, I would not be able to create a NAT gateway and connect it to the subnet because it knows it would clash, it knows it would break things. So if I look at the properties, we'll see this is standard. So you need to make sure you don't have any basic load balancers or basic public IPs in a subnet I want to attach the NAT gateway to. So now I'll go to my NAT gateway. You can see I've created the NAT gateway already, but it's not currently operational. I have to actually add a subnet to it. It has its own public IP. I didn't give it a prefix. One public IP gives me over 60,000 ephemeral ports I can use for various sessions and connections, but I could use a prefix if I needed to scale beyond that. But I'll know that public IP. I could use it and whitelist it on other services. So now what I'll do is I'll go to my subnets. I'll pick a virtual network in the same region. I'm going to link it to my infrastructure subnet. And then I'll save. This is now going to link the NAT gateway to that subnet, and that's it. So that's a huge benefit here. Not only is this a instantly scalable service, it's very simple to manage. That's how hard it is to configure it with networks. I just select the subnets I want to use it. So now this virtual machine is the one that had the public IP address. If I now jump over back to what is my IP, if I run it again, so right now, that was what its public IP address of the VM was. If I go and run this again, I can see it's actually changed. Now its public IP address is that of the gateway. So remember that last number is 142. That 142 is the IP address that the NAT gateway uses. If I went back and looked at my actual virtual machine, its address is similar, but it's a 248. So here you can see now that NAT gateway is being used for its outbound connectivity. I can still get to services on its public IP address that it's offering, but its outbound communication is now going through the NAT gateway. Likewise, virtual machines that are on the same subnet that aren't behind a load balancer, that aren't having their own public IP, will use the same one. So once again, I'm looking for this 1385.185.142. If I jump over to my machine that's on the same subnet, remember previously it had the automatically allocated public IP from Azure. If I check its IP address again, now it's got that NAT gateway. So because it's on, remember I'll paste it in just so we can compare them, it's using the NAT gateway public IP. So now anything on that subnet is just going to use it for its outbound internet access.
So I hope that was useful. I hope now it makes a bit of sense. Please give this video a like, please subscribe, and see you at the next video soon. Take care.